A toy is in the form of a cone of radius 3.5 centimeters. So here we have a cone and the radius is 3.5 centimeters. Now this mounted on a hemisphere. So this cone is mounted on a hemisphere. So here we have this hemisphere having the same radius, the same base, and this is a hemisphere. A cone mounted on a hemisphere of the same radius. The total height of the toy is 15.5. So total height is 15.5. We need to find the surface area. Now just like the other sum, we see that this total height is made up of two parts. One is the height of the cone till here, that is height of cone, plus from here onwards is the radius of the hemisphere. Have you seen this radius? This radius of hemisphere, which is 3.5. So the height, which is 15.5, total height, which is 15.5 in this case, equal to height of cone, this is the height of cone, plus the radius, that is 3.5. So the height of the cone will be equal to 15.5 minus 3.5, and that will be 12 centimeter is the height of the cone. So this height of the cone, now we can mark it. Here it's already marked, is 12 centimeters. We needed to find out that. Now we need to find the TSA of this surface. Let's recollect some of the formulas. We know that the CSA of cone is pi RL and the CSA of hemisphere is 2 pi r square. Okay, so we have to add the CSA of the cone. So this is the CSA of the cone. To that we need to add the CSA of this cylinder. Now all these dimensions, the L we do not know. This L we need to find out. The slant height. Now where is the slant height of this figure? This is the central height. Here, this is the central height, which is 12. This is the radius, which is 3.5. So to find the slant height, we are going to take this blue triangle. Have you seen the blue? It's a right angle triangle. The height of this triangle is 12, which is the height of the cone. And then we have here 3.5 is the radius. And this L is the length. So we'll use Pythagoras theorem in this blue triangle. In the blue triangle, we're going to use the Pythagoras theorem, and we will say L square, hypotenuse square, equal to 12 square plus 3.5 square. So L square is 144 plus 3.5 square is 12.25. And when you add this up, you will get as 156.25. So your L will be square root of 156.25. And if you take the square root, this L works out to be as 12.5. So the slant height now is 12.5. So I've drawn the figure here. So we have two shapes. One is the cone, and of this cone we see the height of the cone is 12 centimeters. The radius of the cone is 3.5 centimeters, and we have calculated the slant height, this slant height here. We have calculated as 12.5 centimeters. And then we have the cone, or we have this hemisphere. In the hemisphere, we need only one dimension, that is the radius, and it is 3.5. Now question is to find the total surface area. Now the total surface area of this figure is made up of this part that I'm darkening again, and that is the CSA of the cone. So we need to find the CSA of the cone, CSA of cone, which you know is pi RL, and the other surface is this, which is now the CSA of hemisphere, which is 2 pi r square, and we need to add both of these. So if you notice, this CSA here is of the cone, and then we have the CSA of this hemisphere, which we have written in this case here. So we'll put the values. Pi RL plus 2 pi r square. We can take pi and r common out. So we take pi r common out. What remains here is L, and in this case what remains here is 2r. Put the value here, 22 by 7. Your r is 3.5. Your L we have already calculated is 12.5 and 2, and we know r is 3.5. And on this calculation we get the answer is 214.5 centimeter square.